In the previous video, I was talking about how restrictive the methods that are available to us to instruct computers. The professionals, the programmers, they are always succumbed and confined to the by the compilers. So the people who design the compilers basically and programming languages basically restrict how programmers could instruct computers. And then as end users, as consumers, it is even worse. We are not only confined by compiler, we are also confined by operating systems of your smartphones and your computers, but not only that, we are largely compiled by the pretty high level applications developers, software developers. We are confined and succumb to their whims in designing the software, and at the end of the day, we only have that few buttons to choose, and we are confined to using those buttons to instruct our device. And in entire scheme of things, from the lowest hardware to compilers to programmers to app software developers and to end users, the end users are being confined by software and app developers. But in the entire hierarchy, the entire continuum, actually, the mobile apps, and software developers are already pretty high level. But the end users are even worse. and and I talk about the reason this is the phenomenon is because computers have no semantics, just like a hardware, like your table has no semantics. It is unable to decipher or comprehend anything. That's very normal, right? They are not real life. They are not automaton, and then people try to give semantics to them. All right, and uh, and but uh, but however, currently there is a huge movement. Of course, the buzzword is artificial intelligence. Millions of developers trying to give more and more semantics to computers, to smartphones, and eventually, hopefully, one day it will be able to be so smart, so sentient, to be able to decipher even what your grandmother says. If your grandmother says something very sloppily, for example, or play some music, then it the most spooky version is that the computers will be able to envision what your grandmother desires and play exactly the song you want, exactly the song she wants. This is the highest level. So we are trying to give a huge semantics to computers. Just like imagine your grandmother tells your grandfather, who is her husband, or please play me some music. And then as your grandfather has already lived with your grandmother for so many years. Your grandfather knows what your grandmother likes very well, so he will play the right song for your grandmother. The reason humans could do this is because human brains have semantics. We are able to know the actual substance of something, but computers are unable to do that. You need to press the button and search for the exact song. And of course, you could say that Spotify would be able to read your preference, but even that, those are quite discrete data. That means it has to compile a large set of data, the music that you have played for the last 365 days, and spot the differences of each song very discreetly. Those are dead data. But however, your grandfather is very sentient. He's actually able to have semantics and decipher things semantically. So people in artificial intelligence is envisioning to do that. One day you will be able to give more and more semantics. In fact, very recently, OpenAI and a non-profit organization in America has successfully developed a codex where you could use English, type in English, it tries to generate a JavaScript code for you. Maybe you could do much better. So the area where computers having three rudimentary operations, read, write, memory, and addition. We try to give it more and more semantics with programming languages, with software, with AI. A lot of people are working on that. But what is more interesting is the reverse. Okay, so just now I said computers have absolutely no semantics. It has only rudimentary operations. Let's look at the opposite, human brains. Human minds are almost orthogonal, almost diametrically opposing. Human minds are human minds are basically a semantical machines. It is full of semantics. We are born for semantics, and it seems that we have almost no rudimentary operations, at least at our current stage, at our current civilization. We are unable to reduce it into a formal, precise, rudimentary operations. Okay, when I say humans are semantics machines, what does it mean? There is a saying that in a Chinese proverb says that there are certain things that could only be sensed and felt. You could never use words or symbols or formalism to really describe them formally. And this is actually how human minds function. We have a lot of semantics in our mind. It's not clear whether humans think in pictures or in symbols, or basically just something very amorphous and nebulous. From my own reflection, last time I thought that yes, I think in pictures, but actually not all the time, because there are a lot of abstract concepts about happiness, about conflicts, about sequences of events in the past. I don't really think about in pictures. I think the shortest explanation is I think in semantics, which is a very amorphous thing. Because deep down, if you really inspect your ideas, your thoughts, they are all analogous matters. It's not a real matters. It's not atomic, definitely. If you study biology, biology tries to model and describe how people are able to perceive things visually, auditorily, and also through touch and sense. Let's take our visual perception, for example. So in biology, the typical model is that your eyes receive light. Okay, the light hits on your retina. Your retina convert those lights into nerve signal, and the nerve cells would send a signal to your brain, your prefrontal cortex, your limbic brain. I'm not too sure, and then you're able to see things, and all that entire process happens within a millisecond. But of course, all these models are this model is actually very crude. It is, first of all, it doesn't explain how does your retina convert photons, the signals, the data into nerve signal. We have no actual model of nerve signal because it seems like an analogous signal. We are not able to formalize it using mathematical notation or linguistic notation. And moreover, also, when the nerve signal reaches your brain, we have no idea how does your brain actually interpret it. Against it, the whole thing is very analogous. And I think this is what semantics really mean. Humans perceive things semantically. We know the meaning. However, we are unable to describe the meaning. So this is exactly the opposite. Computers start out to be very precise. The three operations, read, write, memory, and addition. We try to make it more and more abstract with if-else loop, with pictorial programming, such as the software called Scratch for kids. And then you have end user using a piece of software with a lot of buttons. We are actually trying to make things more and more abstract, from lowest level to at the end only 3 buttons on your software. However, for human minds, we don't start out precisely. We start out semantically. We start out very abstract. we are able to perceive things, ideas, thoughts, feelings in a very amorphous and nebulous way. At least we are not able to model them formally. We started out that, and then very interestingly, we are doing exactly the opposite of what we are doing to computers. Computers, we start out very precise, then when we want to make it more abstract, we compile the abstract thought back to the precise thing, and uh, and in human minds, we are doing the opposite way. We have very abstract thoughts at the beginning, then we try to formalize it using mathematical notations, using languages, be it verbal, spoken language, using hand gesture, using drawing, pictures. We also use, of course, written language. All these notations are actually symbols that help us to formalize abstract ideas. So computers, we go from precise to abstract. Our minds, we go from abstract to more and more precise, to books, to languages, to symbols. And in computers, we have to compile the abstract into the precise. In human minds, we actually want to decompile, I think that is a word, decompile the precise, our books, our pictures, our videos, decompile it back to our abstract thoughts. At the end, I believe it's a pile of nerve signals. So decompile it. I think it's very interesting. We need to try to ask, is it possible to reduce human nebulous thoughts and semantics into few atomic rudimentary operations, just like computers? And I believe it is unable to do so. Basically, currently, language and mathematics is the closest thing we have ever done to try to reduce it. But however, it is not possible to reduce precisely into the fundamental combinations every single human use. So language is the closest, and even language is actually very nebulous, very full of ambiguity, and even language is, which is already of something very abstract in comparison with computers. Even though language is already very abstract, but most people already have a problem of using language, writing, and reading a books. Most people find reading books boring, very restraining, and mathematics is even worse. The reason is, again, human brains are semantics machine. We lack abstraction. We conceive things very abstractly, and if you confine human brains into that few symbols on your books, all right, or even worse, mathematical notations, human brains feel painful because this is not our main modality. At least I think evolution didn't start out in that way, and hence that's why writing and reading is important. It helps you to formalize, but it's also very tiring. That's why most people would rather find watching video more entertaining, watching movies more entertaining, a face-to-face conversation or tactile, real hands-on experience. People want that because reading is too restraining. It's too concrete for human minds. Can you imagine computers? Even high-level programming languages are too abstract for computers. That's why we need compilers. And for humans, it's the reverse. Even books, books, languages are too concrete for human mind. We need to decompile it into videos. That's why people like YouTube videos. Or if you want to decompile it even further, you make it a hands-on experience. People could experience it itself. They could quickly conceive using nerve signals in their mind, so that they don't have to really decompile it themselves. And again, this is a very interesting dichotomy. I think we could, just now I said already, a lot of people are already making progress by making computer more abstract, artificial intelligence. We could make more progress by trying to make abstract human minds more concrete. Could we do more concrete than mathematics or language? I don't really know. Could we reduce into something more and more compact, our atomical few operations of how human beings think? Maybe the neuroscientists are already working on that. I don't really know. It's very interesting. So I will stop here and see you in another episode. Goodbye.